நம்ம சிம்பு ஒண்ணு ஃப்ரீயா எடுத்துக்கிட்டா வேணுமா? ஒவ்வொருத்தவங்களா ஆட் ஆறாங்க இப்பதான்.
Morning, everyone. My voice audible? Okay, so I'm going to start today's session. Okay, good morning, everyone. Sorry for the delay. Actually, there was some net issues we are facing just because the storm came in Delhi. So yes, so we are going to start our today's session. That is second session on the silent power factory. Okay. So here I'm seeing lots of new people have joined the second session. So they are not aware of the basic features and all such things that we did in the first session of the silent power factory. So I will be just going with the quick recap that what are the things we did in the previous session, and then we will start our today's session. So the recap will only take around 20-25 minutes, and then we will do our some of the things, other things that we can perform with the power factory. Okay. So if anything is okay, so should I start? There is chat box given in the screen below. If everything is okay, there is you have no problem, then I'm going to start a session. Okay. So my name is Pallav Harsvardhan Rathor. I, on behalf of Delsoft Technologies, welcome you all for our FDP workshop program on power system design and analysis using the Silent Power Factory software. I'm application engineer, power system division at Delsoft Technologies, and responsible for promotion of the Silent Power Factory software in India. Delsoft, established in 2004, is a research-based company engaged in promoting path-breaking software solutions primarily to the education sector, thereby helping the institute to enhance their infrastructure and provide best possible software solutions. We are sole authorized distributor of Desalan Power Factory for research and education software in India. So yeah, we will keep all your mic on the muted mode just to avoid sound disturbance. You can during the session or any time or at the end of the session, you can write your question in the chat box given in the screen below. After the end of session, we will try to answer all your questions one by one. Okay. So I just welcome you all for this second session. So before going with this, some of the advanced functions, some of the advanced things that I was just going to show you in the second part. Let's start with the slides, and I will just speak, just showing you what are the slides and what are the capabilities of the Silent Power Factory. So yes, so this whole slides, these all such things were in the first session that we did just 6 days before on Tuesday only. So yes. So right now the Power Factory has Power Factory 18th version. Each year they just come up with a new different version. So the slide that I have is of Power Factory 17. But there is not that much difference. So right now the latest version is Power Factory 18 with respect to. I will also tell you how to download the demo version of the software. Some of the important websites of the Silent Power Factory, that from where you can just get some of the knowledge and how we can use the Power Factory. So what does this Desilent stand for? Desilent stands for Digital Simulator of Electrical Networks. It is has set trends in power system modeling for more than 25 years, and integrated power system software is, we can just perform such types of things like transmission for the distribution industry, generation, and the renewables. Now why Desilent? Just leave this. It is because I already done these things in the first session. So this is just slides. I'm just showing you the factory. This slide. So why Desilent? So it is most economical. It is easy to use, and this has various extensive and flexible modeling capabilities. You to just draw a single line diagram and then press execute button, and it will start simulating your analysis part that you want to be. So what's new? Just leave this. These all things what's new and also things you will get in the PDF when you when you download the demos on the software. So these things just leave it for now. Now in the power transmission, again, complete functions for a large internet power system, facts file, API, DPL, Python, these all such things. Now power distribution, for the different phasing technologies, for the multi-phase distribution modeling, for the master radial topology or the railway supply system, and other important aspects are also there, like for the GIS and SCADA integration. So these all things I've discussed already in the first session. So if you want this slide, I can forward to you. But for because as we are running sort of time, so we are just showing these slides, and after that we will start our today's session. So again, same things. For we can perform all the analysis part that are in the power factory. We can perform for the different type of systems like transmission, distribution, industrial system, renewables, power for the generation, and so yeah, I will stop here. So what is power factory base package? Okay, ma'am. Okay, so what is Power Factory 17 base package? So right now this slide is of 17. So in the 18th version, there are some few more things added. There's some of the customization done in the 18th one. So yeah. So in the base package, we have the load flow analysis or circuit analysis. We can model the network. Like for that, we have network model manager and network diagram and graphic features. Now some of the power pin models are there, converter interfaces. We can interface various other kinds of software, uh, GIS, SCADA, MATLAB, and all those things. So it is there. Flow sensitivities, overhead line, cable parameter calculation, resultant reporting, and and at last asynchronous machine parameter identification. Okay, so this was the 17 base package. Okay, and now what are the advanced function that we can perform with the power factory? So these are protection functions, contingency analysis, cable analysis, transmission network tools, distribution network tools, power quality, harmonic analysis, arc lag analysis, reliability analysis functions, optimal power flow, stability analysis functions, RMS, electromagnetic transients, small signal stability, eigenvalues, state estimation, outage planning, what is scripting function, scripting and loss. So these are the uh, whole advanced function. Yeah, in the 18th version, there is some other analysis part that is which are those analysis part. Some of the analysis part are added. So I just remember one, that is probabilistic analysis. So like in the 17th one, they just added one analysis part, that is outage planning. Okay, now in the 18th they have one more, that is probabilistic analysis. So what the thing that we got from the power factory is, in each year they give the new version with a little bit advancement, little bit just with the addition of some of the analysis, and also some of the modification. They create some of the service pack, like in the power factory 17 there was still 6 service pack. So in a month of interval of 1 or 2 months or 3 months, they just provide a service pack. They just give a service pack with a little bit modification. So in this right now we have Power Factory 18 service pack 1. Okay, so until the end of the Power Factory 18, they will introduce some of the changes, and will just name it to Power Factory 18 service pack 2, 3, 4, like that. So this was the whole advanced function and these all things thing. Now I just showed the load flow analysis, how we can perform the load flow analysis, how we can just draw the network and also things. What are the analysis part that we can perform with the power factory? So this was load flow analysis. Now what is this load flow analysis and moment? So the load flow in the power factory is based on Newton eruption technique. So you must be studying some of the other load flow techniques like Gauss Seidel and fast decoupled and all. Lots of load flow analysis options are here to perform. But in the power factory, the default one is only we have just Newton eruption technique. But it has two options for the balance and unbalance. Another one is DC load flow. So this is the load flow analysis environment in which we will get this such thing. And short circuit analysis, I will design a network. I will these things today, and resultant reporting and these all things. So for now, just open our network. Okay, now Start the power factory. It will take few minutes to load. So the power factory 18 service pack 1 that right now I am using. So power factory 18 comes with the two version, that is education version and the research version. So there's a little bit difference in both of the version. But the main difference is only the bus bar limitation. Okay, all the analysis part and each and everything, the examples, the libraries and all such thing are in both, are same in both, for the research and for the education. But only difference is the number of bus bars. Like in the education version we can design for only 50 number of bus bars, 50. Like network more than 50 we can't simulate, then to network more than 50 in the education version. But in the research version we can just simulate for the unlimited number of bus bars. So this is a major difference that the education version, research version has. So yeah, and this is Power Factory 18 Service Pack 2, Service Pack 1. So it will take few minutes to load. Shravan connect over. Okay, so whenever you open the Power Factory, first it asks about the backup and all those things. So just close it. So yes, Power Factory comes with lots of preloaded examples. So here we have application examples, example from the literature, and example from the standards. So if you go with application examples, here we have low distribution network, medium voltage distribution network, transmission system, distant production estimation, industrial network, hydropower plant, wind farm, offshore wind farm, and the railway supply system. Okay. Now, again, in the example from the literature, you will get some of the famous bus system like 9 bus system, 14 bus system, 39 bus system, 30 node feeder, RBTS bus to SAR and VDC. So what we got in these examples. So when you open just lower distribution network, you will get a one running project. So whenever you see this icon, so this means this is the running project. You will just click and this will start in the Power Factory. And what are the things we can perform with? We can just modify the network according to our need. Like I want to design our own, like the best part is we have to never start from the scratch. The whole network is there. With a little bit advancement we can just make just useful to us. So we can do that. Like for the load distribution network, there is one running example, and then there's some of the lots of video tutorials, like for the base model, for the load flow voltage calculation, feeder load scaling, and quasi dynamic simulation, the cable reinforcement. So we will get these things, the videos and the running project with this. Now if we open the medium voltage distribution network, again one running project and lots of video tutorials. So when you will click this video, the link, and they will start open in the YouTube. And there is one page of the disk silent that is on the name of disk silent GmbH, like such. And then you can watch the video from there. Okay, so these are the some of the quick video tutorials. So just give you a little bit idea on how we can just analyze some of the analysis parts given in the Power Factory. Like here it is to type and point optimization, voltage profile, reliability analysis, and all such things are for the better understanding of the software. We can just take help of these examples. Okay, again, same way, transmission system, one project, and some editorial distance protection, stage estimation. We will get one documentation, then how we can create and how we can design network, and how we can perform, and what are the other options we can perform with the state estimation. So we'll get a whole documentation file along with the one running project. Now industrial network, and some of the faculties and some of the research scholar work with the now renewables and also thing. So for that we have hydropower plant and a wind farm and offshore wind farm and the railway system. So these are some of the renewables models given here. So you can take help of these also. Now in the example we have researched some of the basic bus system, 9 bus, 14 bus, these are there. And so these in the example from the standards, these are some of the norms which are related to short circuit. Related to short circuit, this in the power factory, this is very global software, and each country has its own way of calculating short circuit. And so they have given the lots of norms for the calculation is here. So like short circuit environment is like here we have VDE 0102 or ANSI, IEEE, and lots of these norms for the calculation of the short circuit is there. So right now this is 60909, 6090 example 2, and then IC 61363 for the mobile and offshore units. So these are some of the norms. Okay, so these are the some of the example from the standards. So these are the things you can just take help of. Okay, just close this. Okay, so for starting our own project, because these things I've already discussed in this first session, but as lots of new people are here, the second session, so I'm just going once again with the flow, like how to start the power factory and all such things once again. So here we have the file, and then if you go to the new option project, so from here we see three options: project, derived project, and the combined project. So if we open the project one, from here we can specify our name. If you are working on a particular kind of project, we can specify the name. My project name is that is default name, and this is project 127. But just writing or naming the project will make the search more easier. Like if you are working on optimal power flow and all such thing, and at the same time you are working on some other projects also. But if you gave the name to your project, the searching from the whole library of the disk silent, from the project library disk silent would be a little bit easy. So from here we can specify the name, and then just click OK, and then here are some of the things. Just leave it and just click OK. So this is the first view of the software. When you open the Power Factory, we created our project. So we'll be getting this. So here are lots of tabs, lots of bars available to us. Each one have different functions and different name. So let me give a quick recap. That this is main menu bar, this whole one. Here we have lots of menus: file, edit, view, insert, data, calculation, output, tools, windows, and help. If you go with the file, we have new example already shown you. If you have to create other project, go activation and deactivation of project, activation, declaration, study cases, import and export option here. Import, I will show how to import, because these things I haven't just completed in session 1. So I will show how to just we can import the data. Like if we download any file from the from the internet, and we want to just import to the Power Factory and execute it in Power Factory, so we can do that. So in these import options, lots of options are here: export, and these all things. Edit, leave it, and view. We have freeze mode, zoom in, zoom out, such those basic things. In the data, we have data manager, network model manager, leave it. Now here, this is the important thing, that the calculation part of the silent Power Factory. Here we have the load flow, short circuit, contingency, quasi dynamic simulation, RMS-CMT simulation, model eigenvalues, frequency response, production functions, arc flash, cable analysis, harmonic, power quality and harmonics, where we have flicker meter, some of the advanced functions, impedance, frequency characteristics, then transmission network tools. Here we have PV curves calculation, QV, PDTF, and the transfer capacity analysis. distribution network tools, type and point optimization, voltage profile, voltage stack table, backbone calculus, star trace, observer capsule placement. Now probabilistic analysis that I was talking about this one, that is added in this 18th version, that is distribution estimation, probabilistic analysis, and then relative analysis functions added in 16 or something. Then optimal power flow estimation, technical calculation, and then motor starting function and the task automation. So this was the whole NCS part that power factory can perform. Then after performing the power factory, what are the options we have? If you want the output of the just output of the result or output of the things we perform. So here we have cable analysis. So these are the options for getting the output. Some of the tools for the basic change in the user management and all such things. So these are some of the tools. I will not take too much of time in just describing how all of these are tools, because I've already just shown you all these things in the previous session, like how we can take help of the user setting and all such thing. And then what is this? This is windows. If you want to arrange this whole windows according to our need, like this is project overview window. Right now this is ticked. So if you untick this whole project window will disappear. So this is just for the if you want to change the look of this whole software view, so we can do that. And now in the help, this is most important thing that I will show you once again. Like here we have tutorial, start tutorial, user manual, hotkeys, technical references, scripting references, and some of the additional package are here. Now if you go to the tutorial one, okay, so this tutorial of 101 pages, the contents are like introduction to tutorial, documentation and help system, project overview, program overview, how we can create a tutorial project, creating power system elements, data manager, creation of second subsystem, connecting subsystem, motor starting solution, all things. So all those things I have done already in session one, but I will once again just I will give you the quick recap that how we can create a project and how we can connect all such elements of the equipments given here in the library. So this is the tutorial. If anyone wants to get a detailed explanation on how Power Factory works and what are the things we have in the Power Factory, you can go with the tutorial one. And then the next thing is this user manual. This user manual is really enriched. It is of around 1200 pages. You'll see 1200 pages, and the contents are like general information, administration, handling, how we can handle Power Factory, and this part, that is power system analysis functions. Here we have load flow analysis, short circuit analysis. So each of the part, what you get a total theoretical part also, like what does this load flow performs, all the theoretical part, and then the things related to Power Factory. Then what are the things we can perform in the Power Factory? We will get these all things in the load this user manual. Like let me open any one. Let's open this optimal power flow. So this is chapter 48, optimal power flow. Now, what does you will get a one introduction. What does OPF calculation in Power Factory? So, what are the options we have? AC point optimization, DC, these all things related to loss, related to selection, related to load setting. All such things are there. A proper theory, and then how we can use this OPF in the Power Factory. So these all things you will get in the user manual. Okay. Now technical references are real. Lots of models and all such things are given here. If a scripting reference, as Power Factory also has its own programming language, which is based on Python or C++. So if you want to change any module, like we do in the MATLAB, but the MATLAB we have only one option. We have to write code, write a script, and then we can simulate. But here we have options. We can just draw a single line diagram. We can also design the controllers. That one we can perform with the help of DSL, that is the silent simulation language, and the other one is DPL, that is the silent programming language. If you want to modify the things that we can't have in the calculation option, then we can take help of the scripting reference for the learning of the DPL and Python, because I have no idea regarding these languages. So if you are good to these language, so you can take help of the DPL and Python scripting reference. This whole scripting reference is of 600 pages. 700 pages, so you can take help of the DPL function references. But till now I haven't seen much requirement of the DPL and all such things, because you will get your most of your work done by this just designing and simulating with the help of the analysis part that we have. So if you want to learn more, so you can go with these scripting reference also. Then some of the additional package like API interface, DJS interface, these are the interface which the Power Factory just there is Power Factory requires for connecting like if you want the GIS, that everyone must be aware of the GIS, that is geographical information system. If you want the data from the GIS and if you want to execute all this data and you want to collect the data and just want to uh, just make use of those data in the Power Factory. So there is one DGS, that is data exchange format. With the help of that, we can just connect the GIS system and this Power Factory. Now this OPC interface is for connecting the SCADA with the help of Power Factory. Like you must be aware of what does SCADA perform. So if we want to connect SCADA with the help of Power Factory, we can do with the help of OPC interface, and some of the DPL and DSL, these and some of the dynamic C models interfaces are given. So and then this one is what's new that I was talking about, that it is already given in the PDF, so you can take help and just if you want to read, that's what are the new things that we got from the 17.1. So these are this is one PDF and some of the release notes, and then this was whole about the help. So now if we go with this one, this is main icon bar. Here we see lots of icons here for the opening data manager, for a model manager and study cases, and then some of the quick icons for the load flow and short circuit, performing load flow and short circuit, and for the insertion of plot. And so this was whole the main icon bar. Now what is this? This is graphics bar, all things related to graphics, zoom in, zoom out, and the creating of the heat map of the network, animated load flow, introducing title block, just and all the things related to graphs and all such things you will get in this graphics bar. What is this? Is a navigation pane window. Whenever we design any whole any big network, this navigation pane just shows the structure of the network, that how our network looks like. So that's why this we can just see this whole big network, this small navigation pane. So this is forward. Now this is what is this? This is project overview window. It tells us about currently which project is active. Now what is this? This is output window. It tells us about error, warning, information, event, and all such thing. And now this is the whole library of the disk silent Power Factory. And there are lots of bus bars, some of the sites are here, connector and lots of things. Then some of the generation units like external grid synchronous machine, asynchronous machine, WF induction machine, then voltage source are here, line transformers, then some of the power control equipments for the fax devices, then machines, delay model. This was the whole library. If you want to design any kind of network, we can take help of these things. Okay, so this was whole about quick overview that what are the various options, and then what are the names of the various bus bar. So before going with the next thing, then how we can create the network and all such thing, let's see the very important website of the software, that is silent. And those who haven't downloaded a demo version of software, I will tell you how to download the demo version. Okay, so for downloading the demo version, which is valid for 28 days, so it will just go with this site, that is www.desilent.de. This is the Desilent website, and after that just open this desilent.de. You see 3 parallel lines, just click here. And now the Power Factory, the Desilent has various hardwares and various softwares. So like we are dealing with the Power Factory, but here are some of the others software like station wire, Power Factory monitor, and the grid code. Okay, so as we are dealing with the Power Factory, so what we will do after selecting that, we will go with the demo request. Just click on this one, and then what you have to do, you have to just fill this form with this very small form. You just fill, that is Power Factory application. From here you can specify your area of interest. You can fill the area of interest, whether that is transmission, distribution, industry, wind power, PV system, railway, and all such thing. And then your purpose of this, your selection, commercial, research, education, and then what's your title. From here you can give that. and enter name and surname. So, and the most important thing is your email address. So you see there is a written that please ensure that you enter your official company, university, or institute email address, which means we will not respond to Yahoo, Hotmail, or any other public email address. So if you have the email address on your college name or your company name, then only you will get the demo version of software, because the Desalent never provides to any of the personal or the email address like Yahoo and all such thing. So now you just specify your phone number, country, postal code, all such thing, and then submit it. And after it will take around 24 hours, one whole day, and you will be getting your demo, and in which there is a proper email and how we can just download the software and the demo key, and then you can just analyze the Power Factory by using it 28 days. So this is one way you can just download the Power Factory and just analyze and get an idea that whether it is useful for you or not. And if you go with the support option, anyone has any problem regarding how to download the demo version software, they can ask. If anyone just want, okay. Now in the support option, there is one knowledge base website. If you click on the knowledge base website, so this is knowledge base website of the Power Factory, that is FAQ Power Factory. Now here we have around 325 items. So there is a one question and then some of the detailed answer is there. So if we see like how can a simulator network with unsymmetrical voltage and different phase impedance, and what do unsupplied areas and also limited areas mean, how external grid. So there is a lots of queries available. So this the facts and the PV system, these are the various things that everyone is working. So if we go in the facts and just search the facts one. Okay, now one. Okay, now yes, after searching the facts, uh, we have four options. Okay, so here the question is, do you have example of facts? Example that is TCSC model, thyristor control series capacitor, or unified power flow controller, or TCR, that is thyristor control reactor, and the statcom. Okay, if we click on the detail option, then here we have the description is like attach an example of this one. So what we have one PFD format file that is on based on the Desalent Power Factory. This is the Desalent Power Factory extension .pfd. So you just download this Power Factory, and then I will tell you how to import these models, and then we will simulate such models. So from the support option and from the FAQ section, you can take help of the some of the, you will get some of the models, you will get some of the queries, and like let me search PV system also. PV. So you have 9 items, like do you have example of how to use PV system, give example of cogeneration of PV system with diesel and a diesel generation for cost economic simulation, how can analyze microgrid with PV. So in each of the questions you will get one model. See, like this is how can I analyze microgrid with PV and battery system using cost simulation. You just download this microgrid, PV battery microgrid, and then I will show you how we can just open the Power Factory. Okay, okay. So this was the FAQ section of the Desalent, and then if you want to just download a demo, you can take a look of this. Now just move to our software. how we can connect the element, all such things I will be just going somewhat fast, and then I will just take any example and then show you some of the options, like how to just we can connect the element. For connection of the element, what we will do, we will, like, this is bus bar. So just a single click, and with the cursor we have the so as we have the bus bar attached with the cursor, which means right now the bus bar is active. So as many times we want bus bar on our this designing window, we have to click, like I want 3 times. Just click 1, 2, and 3. Zoom it to a level of 75% to make the diagram more clear. Introduce a little bit drag here. Okay, now from here you can, okay, for connection what we will do, simply, like I've just chosen this transformer. So right now we see the cursor transformer has been selected. So what we do is just click once, single click, and drag till here. Transformer connected. For the line, again the same thing, connected, and grid, connect the grid like this, and a load. Okay, so this is the way of connecting. You just saw how simple is diagram designing. You just click, drag and drop, click, drag and drop. Only these things you have done. And what are the options we have in the various equipments? If we go with the transformer, open this. So here we have number of pellet transformer, thermal rating transformer we can change. So if we the most thing we will get in this type option, that is there are 3 types: global type, project type, and new project type. If we go with the new project type, what we do is specify the rated power, rate nominal frequency, high voltage, low voltage side values. We can also introduce the these all things I've discussed in the previous session. I'm just showing you for the better understanding. And then vector groups also thing, you can specify high voltage, low voltage values, positive sequence impedance, short circuit voltage, copper losses, and all such things. For same for the zero sequence impedance. And in the load flow, okay, we can also specify no load current, no load losses, and magnitude R by X ratios. And these are some of the advanced things. I haven't used these things yet, like distribution of leakage reactance in PU. So you can also specify to make your the calculation and also things more clear, so and more accurate. So this was whole in the uh, type option. But again, we have 3 types available, like global type, project type, and new project type. So this was like if we are creating our own project, we will choose this one. But what this is, what this global type is. So global type is there's some of the already feeded data in the silent global library. Like I want the 50 hertz one, so I will choose 50 hertz. Now what type of transformer? Now what type of transformer we have, like distribution of unit transformer. So if you open the unit one, so again the data we have, just click and you will get whole your data here in the power factory. So this is one option of just how we can take help of the global data. So just for now, just close this. Okay, now in the same way you will get for the line also, you will get you can specify the length of the line, derating factor, what is the laying of the line, all the things you will get in the type option. Type, you have to click type, you will again you will get 3 options: select global type, project type, project type. And then the project type you will get 4 options, like line type, tower type, tower geometry. Like if we have the GMD and GMR and all such things, the value of XY, X1, X2, X3, all the data if you have, then we can you can also go for the tower type and the cable definition. So all the things you will get in the type. And also these are some of the options here. So just close this. Okay, now so this way we can just design our network. So right, I will not wasting my time in design the network, because in the previous session I have designed the 5 bus system, and there was I filled the whole data and then executed some of the load plans, all such thing. So in the today's session, it will take around half an hour to design all such thing, then executing those things. So better just take help of the given examples. So if we go with example and open this 9 bus system. Okay, so this is a 9 bus system here, but here we see there is no library here. So what we will do, we will go to the file option and just disable this freeze mode, and now we have our whole library. So what we can do is this our 9 bus system. Now if you want to integrate this 9 bus with any PV system, now I want to just perform any kind of PV integration, want to connect any PV system with on this 9 bus system, we can do that. Then this is the best thing is any kind of modification to these network can be done. Like if we, this is our library, what we will do, if we just select this, delete this delete this element, and then again I just want to add okay. So in this way we can add. Now go to the calculation option and the load flow. And then what are the options we have? Load flow and the calculation method. Already told you that is based on Newton option technique. And then 2 options there, balance and balance. And the last one is a DC load flow linear. So, and then some of the advanced function, you just download the Power Factory and just, we have the other previous session of the FDP on our YouTube page. So you can also refer from there. So these are some of the advanced functions for the active power regulation and voltage reactive power regulation. Then in the controller option, we have active power control according to dispatch, according to primaries. These are some of the balancing functions. So these are some of the advanced functions you have. If you want to learn about what are the changes you will get after selection and after changing the option, you can just refer the user manual. From there you can get what are the uh, what, what are the changes you will occur after just changing the option from reference machine to load a reference bus and distribute slack by loads. So these things are in the user manual, you can take help of that. Now just execute this. Now load flow executed. Let's see the data we have. Okay, active power, reactive power value, and the voltage while. Now this was the load flow. Now next thing is, like, we want how our network areas are behaving, which one has more loading range and has more PU value, all such thing. So for better understanding, here we have the heat map of the network of the, we can generate the heat map. So here we have the resolution. So leave it, just execute this. Okay, so this shows the heat map of the network, that how our network areas and how our bus bars are behaving. So here we see the red color, the yellow color, the light green, more green. So what does this heat map signifies? What it tells? So just okay. So if we have the voltage, lower voltage range ranging from 1 pu to 0.9 pu, so we will be getting these green, teal, and the blue color. If we have upper voltage range, we will get yellow, red, and somewhat the light green. And at last, for the loading range, you will get this. So this was the and how this heat map signifies. So from this, we can get a little bit idea and how our network is behaving and how our network heat map is. Now the next thing is, if you want to generate the animated load flow. So for that, what we can do is, from here they have the option of the layers, and in the layers option we have direction arrows, and right now the direction arrows is visible. Okay, click and then go to the option advanced and animated load flow. Go to the setting option, then animated load flow, and again execute this. So this will start performing the animated load flow, which tell you then how the power and is flowing from one bus to another bus. Okay, stop this. So like this is our network. If you want to generate the whole system report, what we can do is from here, this is the output calculation analysis. Just click it and area complete system report all and execute. Then you will get your whole report in the output window. Okay. Like in the report, what are the things, what are the variables you will be getting, like rated voltage, pu bus voltage, degree, active power, current, voltage, lead, power factor, current, loading. Some of the additional data is here. And then losses, voltage profiles, deviation, all such thing, power interchange, total losses, load losses, no load losses. These all things you will get in the complete system report. Okay. And now if you want to get your all our data from here to MS Excel, what we can do, we do simply go with this network model manager, go the flexible data. So now here we have these data. Just right click and then copy to spreadsheet format, copy with column headers, and just open it the MS Excel. And simply just paste this. So these things can be done. Okay. So this is the network model manager. There's some of the other things, like what are the other things we can perform. We can also plot the graph. So let me just plot the graph, and then what we will do, we will start with the short circuit calculation. Okay. So for plotting the graph, what we can do is simply first go and then insert the plot. Insert plot, this one is one option. From here we can also insert plot, and there is also one quick icon. From here we can also insert plot. So what we are going to perform, we are going to perform the simulation RMS CMT. So we will choose simulation, and then curve plot is this. Just click OK, and then okay. Now, so for plotting the graph, what we have to do is you have to first define the element. So like this is a line. So what we will do is we will select this and then define result for RMS CMT simulation. Select this. This is line 6-9, and let's go with the calculation parameter. Here the variable selection page will open. Go with the calculation parameter and then select the loading line and click OK. Close this. Now go to the curve plot, and here this is our blank plot. Double click anywhere. This page will open. From here again double click. Go with the all calculation. Element you selected is 6-9. Variable was loading. Click OK. Go with the I-axis, and from here we can change the setting, that time setting. I'm going somewhat fast because I will already done these things later. So for this first session, we will be providing you the video link. From there, you can take help of that. What are the things and how we can plot the graphs and all such things. Click OK. Now again one execute a load flow. Here the two options we have: RMS value, instantaneous value, that is electromechanical transients, instantaneous value transients. So execute this one, and just adjust the graph. Let's see where it is. Okay. So in this way, we can get any kind of graph. So this was in the graphics bar, all things related to graphics, like these are the options. You want to arrange plot on top of each other. The arrange plot automatically we can do. This scales x-axis automatically, scales y-axis automatically, and the zoom axis. Now again, if we go to change this to instantaneous value and execute this, and then let's see. It's not plotting. It's not plotting this one. Okay, 1 minute. Okay, so I don't know why it is not plotting for instantaneous values, but in the network representation. Okay, let's choose this one and let's see. Mm, okay, leave it. So this was one variable. If you want to define any other variable, let's go with the this bus, and then again go to define option. Define armature simulation. Now this is bus. Now first delete this element, and now double click and select voltage magnitude already selected and click OK. Close this. Now go to the curve plot, double click here, and bus 6 magnitude OK. Click OK. Now again execute this. Okay, so in this way we can plot for any kind of variable, for the bus, for the line, for the any kind of. Okay, so this was, we executed the load flow. We just performed the heat map. We just got how to, we can get the complete system report, how we can copy all our data from the Power Factory to MS Excel. These things we learned. We already learned in the Power Factory session 1, but we also did here also. Now the things that we will be doing here is, if you want to perform the short circuit analysis, then what are things we can do. So if we go, if you see in the this is the bar of the voltage profile of the buses, the PU values of the bus 1, bus 2, bus 3, bus 4, and all such thing. But if you want to perform the short circuit calculation, and then what are the changes we will get in these. Okay, so for that, just like this is line 69. If you want to create a short circuit here, so what we will do, we will select this, and then we right click, and then option is there to calculate. Okay, so in the calculate option, go with the short circuit. Okay, now the methods that I was talking about, that VDE IEC 60909 in SI complete IEC 63. So these have all these, the methods have different way of calculation. So the default one is, I'm selecting this VDE, that is German standard, and in which year these methods were published. These are the three methods, 16, 2001, and 1990. What is the fault type we have? 3-phase, 2-phase short circuit, single phase to ground, 2-phase to ground, 1-phase to neutral, and all those thing. Now, what we want to calculate? Maximum short circuit and minimum short circuit. That is one thing. Break time, fault clearing time. These all. Now from here we can specify the resistance and all such things. Just write any value, and here we have the relative percentage at which where the short circuit is going to happen. So before it was 50%, it is at the middle of the line. So if you want to change that to 30 or 20%, we can change that. So, and just simply execute this. So you will get, this is short circuit location, and little bit changes there in the graph, little bit dip in this bus 6, but we will see more change if we change the value. Now if you see the short circuit location is this much, and what are the things we are getting? So just right click, and so after performing short circuit, we are getting initial short circuit power, initial short circuit current, and peak short circuit current. Now if you want to add some more variables, what we can do is, this is our format setting dialog box. Then what we can do is right click, insert row, double click here, and then again this variable selection page will open. From here we can just specify some of the other values. and fault clearing time, all such things. So click OK. Okay. Now we are seeing, before there were only 3 data. Now we have these, because I added 4 more variables. So now we are seeing the 7 data. So in this way, we can also get, like, if any kind of analysis the Power Factory performs, the lots of algorithm is running in the background. So we are getting some other variables also. But as the short circuit only shows for the default option, that is our current peak power and the current value and all such thing. But if you want to see some other variables, the way that we get is we just right click and edit format for edge elements, and then from here we can insert the row and we can just add some of the variable. So just delete this. Okay, so this was initial short circuit. This was one thing. Now if you just want to add, if you perform the short circuit by decreasing the changing the values, like go to calculate, and let's see what happens. Okay, so that's, so you're seeing that there's a little bit change after just changing the fault resistance and fault reaction. So that, which means that yes, the short circuit is happening in the circuit, and we're getting, the whole network is getting affected with the help of that short circuit. So if you see in the short circuit option again, uh, okay, and if we go to the calculate short circuit, now the other options are here, IEC 60909. Let's choose this one, change to 2001, and this just relative percentage to 70%, execute this. Now see the changes here. Okay, so this was whatever the norms we have in the Power Factory. If you want to just read these norms, so user manual is there. From there you can refer the user manual, and then you can just perform the short circuit. So this, so what we did, we just learned how we can perform a short circuit, and the load flow and all such things we can perform. Now here we see in the steady cases, there are lots of steady cases here, like 5 cycle classical SG model, 3 cycle classical SG model. Now these are the steady cases. If you want to activate these steady cases, what you do is right click and then activate these steady cases. Okay, so in these steady cases, what we have, we will getting one rotor-Langer curve. Now if you just simply execute this, so we will get one plot of the rotor 5 rotor angle with reference to reference machine angle. So in the same way, we have 5 cycle plus LSG model, 3 cycle SG model, and then if you just open any other one, again one rotor angle with detailed model. Okay, and now IEEE 110. So these were the lots of steady cases given here. So you can take help of these steady cases, so for the better understanding that what are the, how we can just go with these graph and how we can plot these graphs. This last one is comparison of citation model. One minute. Okay, so here we got this graph. Now if there is one analysis, that is frequency response or the Prony analysis. So if you want to perform this, like if you have any graph like lots of variables there, if you have to perform the frequency analysis for those, just right click here, and there is option of frequency analysis. Just select this, and there is select some of the parts of the graph for which you want to perform. Okay, and there is the calculation method is this much, fast Fourier transform and the Perron analysis. So one, select a little bit and execute the fast Fourier. Okay, now if you want to perform the frequency analysis, Perron one, this is maybe to select more. Um, okay, so now Prony started. Prony plots for frequency, damping, amplitude, and energy for like in the discrete intervals of time, and the next one is signal to noise ratio also. So these two things the Prony performs. So now as the Prony is running, what we can do is we can just simply go with the this option with the our FAQ section, and what we can do is we can simply download our some of the facts file and all such thing. So first download some of the models, because I have to tell you how to we can just import the file. Okay, now open this, download these models. Okay, so we downloaded example TCSC PFD again, just 2 or 3 models just to demonstrate how we can just import the models. Then UPFC also. Okay, this much is enough, and some of the PV systems also. Mm, okay, now if we go with the PV, and then open anyone, and then download this model. This must be enough just to how to demonstrate how we can import and export. So just Prony completed, so it is just plot for frequency, damping, amplitude, and energy, and the signal to noise ratio graph. So this was whole about how we can just load flow and how we can just take help of the steady cases. So this whole thing. Now if you want to just import any other project from, like if you download, I downloaded from the FAQ section of the Desilent Power Factory, and if you want to execute in our Power Factory, so what we can do, you have to, like this is one project is right now currently active. So if we activate import the any other one, it says import is not possible, project is active. Regarding your queries, I will resolve all the queries after the session ends, because some of the other people's who have no idea regarding the basic functions of the Power Factory. So I'm just going with the flow, and after this session will end, then I will resolve your queries. Okay, now as we see right now, the currently one model is running. That's why. So for importing, what you do is first you have to deactivate the project. So right now this project, I deactivated the project, and just clear all. Okay. Now this is our project, and this is our like we deactivated our project, and right now we're seeing gray color, which means there is no running project. So then now what we will do, we go to import option, and then data, select, and here we have some of the files that we downloaded from the FAQ section. So like this is example.tcsc.pfd. Open this, and after opening the importing this tcsc file, what we have to do, we have to go to file and then activate that project. So we will search for tcsc and open this. So this is the whole tcsc model, generator, transformer. This is given already given in the Power Factory. Okay. Now, what are the plots that we are getting here? Like we are getting general plots, TCSC plots, TCSC frame. This is frame diagram. TCSC control. That is, if you want to design the controllers, that this is the TCSC control. And at last, the eigenvalue plot. Now, if we go with the TCSC plots, let's first execute the load flow. Okay. Now load flow executed. Let's see the heat map, how does that network looks. So this is the heat map of this TCSC model. Each transformer is loaded, and then if we go with the plots, like we on the plots, so this is interest speed and all such thing. What we will do, we'll select RMS value, and then we will plot for 5 seconds. So this will plot TCSC. Now if we again go and change this to instantaneous value and decrease this to 3 seconds. Now this plots for the electromechanical transients. So this is one thing we can do. Okay. I just selected for the 3 second. That's why the graph plotted for the 3 second. So here in this way, we can just import our any of the project, any of the example that we download from the web internet, and then first deactivate it and then activate, and then we can just use these models, and you can modify these models whatever you want. Okay. Now for the eigenvalues plot, what we do is we will go to perform the modal analysis. Okay. So for that, go with the execute, and what we do is we will go with the modal eigenvalues. Okay. And now execute this, and this is our eigenvalue plot. Okay. Now, if you want a data, like after this model eigenvalues plot that is ready, if you want a data of what are the values of R and 1 by S, so modes and states. So here there is option, click here and execute this. This is so for a real part, imaginary part, angle, damped frequency, period, damping ratio, damping time constant, and A1 by A2 ratio. The whole thing of the all the modes that comes in this network, we will get the whole detailed analysis result of the eigenvalues in this format. Okay. Now, if we are go with the states and execute this, some of the more detailed data for the generator to speed, TCSC frame, whole. Then we get whole network after plotting the eigenvalue analysis. Now in the eigenvalue analysis, there are some of the other graphs that can be plotted. So those are like here we have this is eigenvalues. Now two other plots are here also, mode bar plot and mode phasor plot. So just select this and click OK. And here are some of the real part in this zone values, controllability, observability, some of the advanced function. I have not that much idea regarding these things. Click OK. So it will plot for the circular one. And now for the mode bar plot, execute also, and then OK. And 4, it will plot for the mode bar plot. So here 3 plots are there in the eigenvalues. So in this way we can plot for eigenvalues. First we have to do we have to execute the load flow, because sometimes that like this network needs unbalanced load flow for getting the eigenvalues plot. Like let's see, I'll first go and activate the AC load flow and execute this. Now plot the eigenvalues and just see what it tells. Now showing any problem. Okay, so in this way we can we just like I just opened a model and we get some of the plots, generator plots, frame and controllers, and the eigenvalue plot. So this was how we can just import our any kind of example. If we just open, and because I'm seeing lots of queries regarding the renewable energies. So if we for the yes again the for importing in the project, first we have to deactivate this and then again go to import. Let's see one other effects file, that is a statcom, and where it is, generate statcom model. Open this. Now activate generate statcom. Where it is. So this is the statcom frame, and this is the network diagram of the statcom. Let me external grid. There is a medium voltage substation, then cable, medium voltage node is there, statcom transform then one motor is there, low voltage node, statcom, PWM converter. All these things are in the library. Here we have this one. Okay, now DC capacitance, DC bus bar, and all such things. So here you see the libraries is totally enriched for we can design for any kind of network. So this is the statcom frame. The one of the plots we have simulation plots. This is controller block diagram, and this is statcom frame. These all things like statcom frame and the controller block diagrams we will get we will learn by with the in the DSL option. So if you again open and execute this, execute this. So this is the graph. Now if we again we go and just change this to instantaneous one, execute this. So this is the instantaneous graph. So in this way we can just import any of the project. Now if we go in the deactivate this project and import any PV system. Import, search for any PV system. PV system.pfd. Open this and activate once again. Okay, open this. So this is the network. External grid is there, transmission line is there, and one PV system is connected in low voltage, so there is a breaker is there, then PV system. So this is one project, one PV system project, but we have lots of other also, like if you want to see some other, so open this one, microgrid one. So this is different one. There is diesel engine attached, then this is medium voltage bus. This is practical example, like this is industry and what PV system is connected, and the line is there. This is down to residential area, residential value. Now this is a residential complex. There is one renewable source, that is BV batteries attached. Now this is market, and at last this is one farm. So in this way we can design for PV system. And what are the options we have in the PV system? Just open this. Now the technology we are doing is 3-phase, 1-phase technology there. Plant categories you can change, and number of panel units, nominal apparent power, power factor. So this is the basic things. Now for going with the more option, uh, okay, let's connect any PV system, then see. The PV system. Open this, and now active. Yes, there is two options: active power input and a solar calculation. So these options, like number of parallel inverters and nominal apparent power and power factor, is for the active power input. If we select this to solar calculation, we will get the type option. The type option, again go to new type, project type, and from here we can specify the peak power, rated voltage, rated current, open circuit voltage, short circuit current, and the material. What kind of material it is, whether it is single crystalline, polycrystalline, amorphous silicon, copper indium selenide, and cadmium telluride. So in this way, we have two options: solar calculation and active power input. Now, if you again go to the type option, click on the global type, and here are some of the brands, some of the companies which manufacture the PV cells, like Alio Solar Avances, BP Solar, Boss Energy. Click anyone, and then you can simply click, and we get all our data in our network. Like this is the this name, P power is 130, rated voltage, this whole thing. So in this way we can design for the renewable related to PV system. We have lots of global values and all such things given in the global library that is silent. And so yeah, this was the PV system. Now if we go with the file option and open the example, then here we have I'm seeing there are some of the queries regarding a wind farm. So if you open the wind farm, and there is an example of 15 megawatt wind farm, 6 turbines. So if you open this, so this is the wind farm. So this is 20 kilovolt grid connected. This is supplying power, and then distribution network bus bar. There is line is there, wind farm substation bus bar, and at last here it is, the transformer is there, and then wind turbine control. There is wind generator is there. So this is the whole wind turbine here. Okay. Okay, so this is the whole network. So I was seeing some of the queries regarding the wind farm. So so what are the things you want to perform in this wind farm? Yes, ma'am, your question was models in the website is in different version. No sir, it can be used, like if you have the 18th, right now I'm using the 18 version of the desalination power factory. So yes, I can use the models given. Change in speed and simulate. Okay, let me check change in speed graph. Okay, first receive the load flow. PQ change. Change in speed. Let 1 minute. It will take few minutes to execute, but I think ma'am change in speed can't be plotted because this software is like this is the wind generator is connected, so from that it is getting power from the whole system. So change in speed is maybe you can simulate for those system which work for the designing of the wind controllers and all such thing. Here we can get our reactive power and active power and all such data, but the change in speed, power curve is there. And I think there is no study cases regarding the change in speed. Wind, wind turbine model. Okay, let me check. Wind turbine model. I'm right now just see in the example option. We have only these options like hydropower plant is there, and then wind farm is there. So this is the examples of 15 megawatt wind farm containing 6 wind turbines with a fully rated converters connected 20 kilovolt grid. And the other one is offshore wind farm connected with HVDC link. Okay, so these are the two models. So whatever the model is of your need, just tell me, I will execute these. Because those the things you are asking, that the wind speed and all such thing, I think those variables are not here, but I will search and then I will respond to you later through mail. But right now I have no idea regarding these the wind option, because this is the wind farm, and here we see this is 15 megawatt 6 wind turbines. So if we move to our grid, so this was 20 kilovolt and this was a 6 wind turbines connected. And here in the steady cases we are only getting VQ and PQ curves and harmonics and all such things. But the related to wind speed, I think there is no such variable. Let me check once. If I will define this, and uh, UERT. What are the other parameters monitored from the wind turbine model? So what kind of parameters you are asking? Wind speed. Okay. Actually, your requirement is of wind speed. Okay, okay. Rotor current, wind speed, all such thing. Okay. Mm, stator current, active reactive power torque. The active reactive power torque, these the active and reactive power, these are possible, but these things like wind speed, right now I have no idea regarding these variables, but let me check once. this is, if we go define, see, can we model the wind turbine as synchronous machine or random machine as per our requirement? Winter. So this is one model given just for the basic understanding, and this is the already this is a preloaded example. But if here you must already seen there is lots of libraries there. So uh, if your schematics is ready, that what are the things you want to perform? Virtual power plant. Um, Regarding virtual power plant, and let me check in the this FAQ section, because the model, I don't have any model regarding the virtual power plant and all such thing, because we have only the model that I shown you, the wind farm and that offshore wind farm. So let's search. So, wind. Um, okay, let's search virtual. No, there is no virtual wind farm in the box. Ma'am, right now regarding the wind farm and all such thing, I can't help, because right now there is no made model from the Dissilent also. I also don't have any model, but what I can do, I can just ask from the Dissilent Germany, the support website of the Dissilent. Then if they have any model, or if they have a link that where to download those model, then I can provide you. And yes, yes, yes. And regarding those your query, the variables that you want to perform, like wind speed, rotor current, I will search those variables if they are available in the, like, lots of, in the variable selection page. There is lots of variables are there, but maybe I haven't seen this wind speed, so I will search these variables like wind speed, rotor current, and stator current, and then I will and I will show in the later sessions if I will get these of the variables. Because right now there is in the FAQ section also there is no any wind model is there, only because in the example option there is two models, that is wind farm and the offshore wind farm is there. So regarding that I can't help right now, but I can ask from the Dissilent Germany that if they have any model, so they can provide you that. Wind turbine. हटा लिया हटा लिया उससे कर लिया. And here I got one model that in that example, अब ये नहीं पता चल रहा है. And this is one model of the wind turbine driving an asynchronous machine, that is fixed speed WTG.PFD. Their reactive power, and this is whole description. So if you want to just import this file, and this, if this is of your requirement, I can do that. And 1 minute. open this. Let's see. And this is one model of the wind generator, and this is what the graph is. This active power in PU and total reactive power in PU, and the next graph is of positive sequence current and real part inside in PU, and the next one is and line to ground voltage magnitude for the generator. This is mechanical and electrical torque, and this is a frame, and this is a shaft. And at last, this is a turbine model. So these are the variables that I got after importing this one. That is active power and total reactive power, and positive sequence current and real part side in PHU, and then line to ground voltage, and at last this one, the mechanical torque, electrical torque. But regarding the wind speed, I have to search. But these variables that I was saying, active power, reactive power, torque values, and the current and the voltage magnitudes, these all are in the variable selection. But I haven't seen the speed, so I will search it and then I will respond to you. Anyone, any other query regarding wind turbines and all such thing? Solar radiance change. No, I have no idea regarding this also. Actually, I'm writing down your all your queries, and because in the next session I have 7 days, so I will search and then I will ask from the support website of this talent. So if they have any, if they reply me, then I will give you, because solar radiance change and these things are, I think this is for the power system modeling or designing of the network. So here we have only models like there is wind generator, there is a synchronous generator, or the battery storage, or the PV system. And these irradiation change, I think these are for the network in which we just model the PV system, we create the solar panel cell. I think because there are some other softwares we just who just create the PV panel cells and all such things. So as this is the power factory software, so I don't think these are the options we'll be getting in this one, because here we are only usually only deals with the analysis parts that we have: load flow, source, circuit, contingency, production actions, and usually the active power and reactive power, the values, the current, the voltage and magnitude. So but I will ask these queries regarding the wind speed and the solar irradiance that you asked. Yeah, the MATLAB to the silent interface is possible. There is one model that I have. From that, we can just interface with the MATLAB. That interfacing is possible. There is one video tutorial also in the YouTube, in which there is two area system. A network is designed in the silent power factory, and the PSO algorithm is written. The script is written in the MATLAB, and after that these both are integrating with each other. The number of iterations and number of lots of things are changing in the MATLAB, and that whole change is reflecting in the power factory. So yes, MATLAB to digital interface is possible. Yeah, there is one video, and you can search, just write MATLAB desilent communication procedure, you will get that. Okay, so there is one more thing I have to show you, the library of the DSL, because I was seeing lots of queries regarding the controller designing. So this was whole about the some of the basic functions of the Power Factory, the single line diagram designing, all such thing. But if you want to design your old controller, sir, actually we are facing the net issue because last night the storm came. So that's why we are facing some of the net issue. That's maybe. So you better watch that video in the YouTube and how to integrate MATLAB to the software. In the YouTube, there is one video that is MATLAB and the silent communication project. Just search that MATLAB communication project, and there you will get one video regarding how to integrate MATLAB to the software. Okay. Now I was just showing you the library of the DSL. Okay. Now this is the addition page. Like if you want to just click here, and here it is, the like right now we're using single line graphic. So if you want the block frame diagram, select this and execute. So this is our block field diagram, and now here we see some of the other library we are seeing. Like here we have some of the slots, block reference, summation point, multiplier, and all such thing. So if we open the block reference and double click here, and then this will open, and then go to the type, and then three options there: select type, project type, new project type. Go to the global type. Okay, so here the already given macros available to us. These are macros of the first order function, second order functions, some of the deadband, delays, gains, limiter, lodging function, lookup tables, math function. So if you open the first order function, so these are the transfer function given, already given in the Power Factory. These are some of the macros given in the Power Factory. So we can simply take help of these, like just click, and this will open in your block. Just click here and okay. So see, this came in your block. So in this way, all those control that I was showing you can be designed from the DSL page. That is this block frame diagram. Now what you do, only select global type. These are the norms here. Lots of options. Okay. Now for the second order function, again you will get these things, these macros. Now these are for the dent bands. Delays is if you want to introduce a delay. Gain, for introducing the gain. Logic functions. Okay, lookup tables, math functions, all such thing. Now the rest is PSS compatible. Then these are the AVR frames given. Now these are the AVR frames given here. AVR, governor, block diagram, PSS, SVC, and UEL. So let me open anyone. Click OK. Okay. So this was the AVR flame. So in this way, like this is one thing. Now for connection, just start with this, and this is output. So in this way, we can design the controllers. Now if we open the type, and there is other type, that is new project type. The new project type, what we have option of DSL model we can select. We can get compile model or the MATLAB M model. From here we can just search for the MATLAB file, and we can just model the whole network that we created on the MATLAB, and we can just copy, and then we can execute. So in this way, we can just design the controllers, because you see all the libraries there. Just create, just add one other block, introduce some of the macros, or if you don't have the macros, just create your own from the new project type. Like you have to specify output, input signal, state variables, parameters, internal variable, and some other input signal losses thing. And in the advanced option, there's some of the advanced option is there. Okay, and if not, so better just go with the global type and search here, because lots of macros for the first or second order, then some other lots of AVR, PSS, all things are available here in the global library. So you can take help of these also. Okay. So yeah, if anyone has any query, they can ask, because I'm going to end the today's session. And in the rest of the session, we will be doing hands-on, and there were some of the queries regarding the usually the renewables queries on how we can perform the wind farm speed and all such thing. So I will search for those queries. I will then come back with those queries if possible. Ma'am, better just to download the research version, because in the education version there will be limitation of the 50 number of bus bars. Then if you have option, then why to download the lesser number system? Better just you download the research version in which there is no limitation of the bus bar. Yes, actually we are facing the net issue, because in Delhi the storm came last night, so we are just that's why maybe you're not getting the video. So when we just download the research version, because in the research version there is no limitation of the bus bar, and after registering it will take around 24 hours or one whole day to get the proper mail, in which there will be one email ID and password from and you have to go to download area. From there you have to download it, and then from the you will get one key, and you just fill that one key, and then yes. And if you have any query, then you can ask. Otherwise, will I'm going to end the session. And as yes, there are some of the queries that I was not able to resolve today, so I will just go with those queries, because I have 7 days of time, and then we will in the next session I will discuss those queries. I just want to tell, because you are already research scholars and MTech students, so you just better download the software, and you just search that what the capability of the software. That will be easy for you also for the better understanding, because software is demo version valid for 28 days. So you can use the software. You can better just get what are the capabilities of the software, and then we will learn more faster. Any other query? If any, yeah, you can ask. Hmm. Slower. This is my email ID and my number. If you have any query regarding the, if you're facing any problem in downloading the demo or any such thing, you can just contact me on this number or email me. Already told you this. There is one our YouTube channel name of the Delsoft. There's some of the previous webinars. From there, you can also learn some of the things. Okay, so I'm going to end today's session. Thank you for joining, and we will meet in the last session, in which we will be doing the hands-on, and I will be resolving some of the queries that I got today. And regarding certificates, you will get the certificates in 7 days. 7 days. After the end of the third session, you will get your certificates. Okay. Thank you, everyone. ये सब भी दिखाता है